Have you ever looked up at the night sky and wondered about the vastness of space? The universe is so immense it's almost beyond comprehension. It's a place of incredible beauty and mystery, filled with countless wonders waiting to be discovered. Among the twinkling stars, a truly spectacular event occurs from time to time. This event is a supernova, one of the most powerful and awe-inspiring phenomena in the cosmos. Imagine the biggest explosion you can possibly fathom. Now multiply that by 1 billion times. The energy released is almost unimaginable. That's the sheer power of a supernova. It's a cosmic event that can outshine entire galaxies. These stellar explosions are not only incredibly powerful, but they're also incredibly important. Why? Because they are essential for the creation of elements that make up everything around us. That's right. The very atoms in your body were forged in the heart of a dying star. We are quite literally made of stardust. Intrigued? Let's delve deeper into the fascinating world of supernovas. We'll explore what they are, how they happen, and the incredible impact they have on the universe we know and love. Get ready for a cosmic adventure. The journey through the life and death of stars is just beginning. In the vast expanse of space, stars are born. They shine brightly for millions or even billions of years, and eventually, they die. This life cycle of a star is a fascinating journey, filled with stages of growth, stability, and finally, decline. But not all stars fade away quietly. Some meet a spectacular and cataclysmic end. These dramatic endings are not just random events, they are the result of complex processes that have been building up over the star's lifetime. This is where supernovas come into play. A supernova is essentially the explosive death of a star. It's a phenomenon that has intrigued scientists and astronomers for centuries. It's a cosmic event of unimaginable power. Imagine a star, much larger than our own sun, suddenly releasing as much energy as our sun will emit over its entire lifetime, in just a few seconds. The sheer magnitude of this energy release is almost beyond human comprehension. That's a supernova. This explosion is so bright that it can outshine an entire galaxy for weeks or even months. The light from a supernova can travel across the universe, reaching us here on Earth, allowing us to witness these incredible events from millions of light years away. Can you believe that? It's like a cosmic firework display on a grand scale. These explosions are not just visually stunning, they are also incredibly important for the cosmos. But supernovas are much more than just dazzling light shows. They play a crucial role in the evolution of galaxies and the universe itself. The elements created in these explosions are scattered across space, seeding new stars and planets, and contributing to the ongoing cycle of cosmic creation and destruction. So, what causes these celestial fireworks to erupt? To understand that, we need to delve into the heart of a star. Stars are giant balls of gas, mostly hydrogen and helium, held together by their own gravity. They generate energy through nuclear fusion, converting hydrogen into helium in their cores. This process releases enormous amounts of energy, which is what makes stars shine. But eventually, a star will run out of fuel in its core. When this happens, the outward pressure from nuclear fusion can no longer counteract the inward pull of gravity. The star's core collapses in on itself. This collapse happens incredibly fast, in a fraction of a second, and it triggers a shock wave that rips through the star's outer layers. The shock wave is so powerful that it blasts those layers into space at incredible speeds. Boom! That's a supernova. Now that we know how these cosmic explosions occur, how do we even know they exist? Well, supernovas are incredibly bright. They release an immense amount of light, making them visible across vast cosmic distances. Astronomers can detect these sudden bursts of light using powerful telescopes. But there's more to identifying a supernova than just its brightness. Astronomers analyze the light from these explosions, breaking it down into its different wavelengths. This is called spectroscopy. By studying the spectrum of light, they can identify the elements present in the supernova explosion. Each element has a unique spectral fingerprint, like a cosmic barcode. This allows astronomers to confirm whether they're observing a supernova and determine what type it is. It's like cosmic detective work. Section 5. Stardust Legacy. The cosmic remnants of a supernova. Supernovas are like giant cosmic factories, forging new elements in their fiery furnaces. When a star explodes, it doesn't just disappear into nothingness, it scatters the elements it created throughout its lifetime into the vast expanse of space. These elements include carbon, oxygen, nitrogen, iron, and many others, the very building blocks of planets, life, and even you and me. Yes, you read that right. The calcium in your bones, the iron in your blood, even the gold in your jewelry were all created billions of years ago inside the heart of a dying star. These elements, scattered across the cosmos by supernovas, eventually become part of new stars, planets, and even life. So, in a very real sense, we are all made of stardust. How amazing is that? Section 6. Variety in Destruction, Unveiling the Different Types of Supernovas. Not all supernovas are created equal. These cosmic explosions come in various forms, each with its own unique characteristics and origins. Just like there are different types of stars, there are different types of supernova explosions. Each type tells a different story about the life and death of stars. Astronomers classify them based on their light curves, how their brightness changes over time, and the elements detected in their spectra. These observations help us understand the underlying mechanisms driving these powerful events. One major type is called a type Ia supernova. These are particularly important because they serve as standard candles for measuring cosmic distances. These occur in binary star systems where two stars orbit each other. The interaction between these stars can lead to dramatic outcomes. If one of these stars is a white dwarf, a dense, Earth-sized remnant of a Sun-like star, it can steal material from its companion star. This process is both fascinating and complex. This can trigger a runaway nuclear fusion reaction, causing the white dwarf to explode as a Type Ia supernova. The explosion is incredibly bright and can outshine entire galaxies for a short period. Another major type is a Type II supernova. These are equally spectacular but have a different origin. These occur when massive stars, much larger than our Sun, reach the end of their lives and collapse under their own gravity. The core collapse leads to a cataclysmic explosion, scattering elements across the cosmos and leaving behind a dense neutron star or black hole. Section 7. Not all stars go out with a bang, the stellar afterlife. It's a common misconception that all stars explode as supernovas. In reality, only a small fraction of stars are massive enough to meet this explosive fate. Our Sun, for example, is not massive enough to become a supernova. So what happens to stars like our Sun when they die? As they run out of fuel, they expand into red giants, shedding their outer layers into space. These layers form beautiful glowing clouds of gas and dust called planetary nebulas. The star's core, however, shrinks down into a dense, hot object called a white dwarf. White dwarfs slowly cool down over billions of years, eventually fading away into darkness. So, while they don't go out with a bang, they leave behind their own unique mark on the cosmos. Section 8. Echoes of Creation. The profound impact of supernovas. Supernovas are not just destructive events, they're also incredibly creative forces in the universe. The shock waves from these explosions can compress nearby clouds of gas and dust, triggering the formation of new stars. In a sense, supernovas sow the seeds for future generations of stars and planetary systems. Moreover, the heavy elements forged in supernovas are essential for the formation of rocky planets like Earth and the building blocks of life itself. Without supernovas, our universe would be a much less interesting place, devoid of the diversity of elements and planets we observe today. So, while supernovas mark the end of a star's life, they also represent new beginnings, paving the way for the formation of new celestial objects and the possibility of life elsewhere in the cosmos. Section 9. Hunting for supernovas, peering into the distant universe. Astronomers are constantly on the lookout for these cosmic explosions, scanning the night sky for telltale signs of their brilliance. They use powerful telescopes, both on the ground and in space, to detect the light from distant supernovas. One way they hunt for supernovas is by comparing images of the same patch of sky taken at different times. If a new bright object appears in the later image, it could be a supernova. Another way is to look for sudden changes in the brightness of distant galaxies. Once a potential supernova is detected, astronomers use spectroscopy to analyze its light and confirm its identity. By studying supernovas, we can learn more about the life cycles of stars, the expansion of the universe, and the origins of the elements that make up everything around us. Section 10. A universe transformed, the enduring legacy of supernovas. Supernovas are among the most powerful and influential events in the cosmos. These explosive stellar deaths not only mark the end of a star's life, but also play a crucial role in shaping the universe as we know it. They scatter the building blocks of planets and life, trigger the formation of new stars, and enrich the interstellar medium with heavy elements. From the calcium in our bones to the iron in our blood, we owe our very existence to these cosmic explosions. As we continue to explore the universe, supernovas will undoubtedly continue to captivate our imaginations, revealing new secrets about the cosmos and our place within it. So the next time you gaze up at the stars, remember that even in their death, stars can create something truly extraordinary.